Hello, in this lesson, we're going to talk about the composition of tangent and arctangent. Here, once again, we recapture the definition of function, right? So here we're dealing with two functions. And so each one individually is a function. It is a function. Tangent is a function, which means that it has its own domain. And for each input from that domain, it produces exactly one output. Arctangent has its own domain, and for each one of its input, it produces exactly one output. So that's the context we're in. And of course, these two are trig functions. So we are doing all of these in the, on the stage set of trigonometry, which is the three pillars, right? The three pillars. Number one, angle measurement, right? How angles are measured. Counterclockwise, positive angle. Negative angle are measured clockwise. Reference angle are positive acute angle between terminal and x-axis definition. So in this case, we have in the definition, of course, we defined, six functions, and A is an angle in standard position, and a point x comma y is on the terminal side of the angle other than the origin, which guarantee that r is going to be positive. For tangent function, of course, we know its definition. Its input is an angle and the output is a ratio. And we discuss its domain is all real numbers, but, right? All real numbers, but. So here, this piece should be read as all real numbers, but odd number multiples of pi over 2. Okay, so I'm going to write that down, write that word down. Okay, how do we read that, right? The narrative for that domain is right here. Okay, all real numbers except, okay, we can use a word, right? Odd number multiples of pi over 2. Pi over 2. Okay, so that's the narrative of the domain. Or you can also use more symbols, right? You can say all real numbers except, right? All real numbers except part, except that A is, actually we can just write this, except that. Okay, so we can use, when you read these are the wordings you can use. Range from negative infinity to positive infinity. We have summarized about these two functions, about this tangent function, and we know its graph, right? And this one, right, is domain, all real numbers other than the odd number multiples of pi over 2, and the ratio can be any real number. We had a detailed discussions about it. Arctangent, however, okay, this, we know tangent does not have inverse because it is not a 1-to-1. So we created an arctangent. Okay, we create an arctangent, and this arctangent has a domain which takes ratio from, ratio can be any real number, produces output that is an angle between negative pi over 2 to pi over 2. In fact, this arctangent is the inverse function to this tangent, which only the middle piece, the piece in the middle from negative pi over 2 to pi over 2 is discussed, right? So these two functions are inverse to each other. And with that said and done, we mentioned that the inverse of arctangent is rarely talked about. Whenever it is talked about, it will be talked about in the context of for tangent, which always refer to this one, unless otherwise specified. So in this case, if you do want to mention the inverse of arctangent, you just mention tangent with specific interval. That's how you would mention the inverse of arctangent. In most of the cases, we are only just dealing with these two. Okay, and of course, we have some interesting shortcut as a result, because of these two are inverse to each other, right? So first, let's address this issue. So I'm going to copy and paste this piece and just put it over here. Okay, just put it over here. Since we know these two functions are inverse to each other, right? Since we know these two functions are inverse to each other, so we will have the following, right? We'll have the following. And what is it, right? We know that for any one-to-one function, right? This is a one-to-one function and this is a one-to-one function, and they're inverse to each other. One's domain is the other's range and vice versa. And their input output just simply swapped, right? So we're in that situation. With that understanding, we know, right? So we know this property, okay? For any, one-to-one function, okay, for any one-to-one function f and its inverse, we know that it has an inverse, right? What do we have? If we composite them, we have f composite f inverse of x is going to equals to, right? It's going to equals to x provided, okay, they each have a domain and range. One's domain is the other's range. And this x is from the domain. It's from the domain of f inverse. Because f inverse rule, right? We know function of the rule. The rule of f inverse apply to x first. Therefore, this x has to be in the domain of f inverse. And, okay, f inverse composite f on x, and this time x is from the domain of f. Okay, because the rule of f applies to x first. Okay, so this is the property that is true for any pair of function, and its inverse, one-to-one function and its inverse. Okay, and it certainly applies here. Okay, so we have our f inverse here, right? So what I'm going to do is that I'm going to post this beneath the form, right? We're going to have it here. I'm going to apply this property. Okay, and let's see how we compose it. Okay, our f is arctangent. Our f inverse is tangent, where x is from this interval, right? You see, one's domain is the other's range. Right? Everything matches perfectly. So this f is going to be arctangent of, now f inverse, so that's going to be tangent of x. Okay, and we're going to attach this piece. So x is going to be from the domain for the F inverse. And the other one, if we translate the other one, right, F inverse is tan, right? Tan of, over here, F is arctan. Arctan. And of course, this x is going to be ratio, right? Arctangent takes ratio. So even though they're both called x, okay, even though they're both called x, they are totally different in meaning. They're totally different in meaning. We've been addressing this for sine, cosine. Now it's for tangent, okay? So these two properties applies. Okay, these two properties apply because these two functions are inverse to each other. Now, this condition actually is not really a condition because this basically tells you for any real number, this is going to be true. So if we remove this, right, it will be fine. If we remove this, right, if we remove this condition, it's true, okay? Because it's any real number, right? So these two properties are primarily used to handle the compositions of tangent and arctangent in different order, right? In this order, you can see x is the input for tangent. So it will be considered a radian, right? It's from the domain for tangent. However, for this one, we cannot remove this condition. We cannot remove this condition. This condition is indispensable because of this relationship. Okay, so we're going to see some examples soon. And here, this x here is, has the arctangent rule applied to it. So this x is considered to be a ratio. So any number you put here, it will be regarded as a ratio. Okay. So now let's look at some examples. Right? We know the domain and range, and we have done much of these, the tables. We did the tables. Let's see, I think we have another table, didn't we? Tangent, arctangent. I didn't copy that arctangent table with us over here. Okay, I'm gonna find the other arctangent table and bring it here with, closer to us, right? So in case we need that. Where's my arctangent table? I thought I have it pretty close to me. No, hold on. I don't think it goes any deeper. All right, I shall find it. Just give me a second. Okay, I found it. Okay, so we're going to bring these two together. Okay, in case we need it. Right? Hold on, let's see if I can put them on the same row. Oh, it's there. Actually, they're there. Okay, they were there at the beginning. It's just, okay. No problem. This is good. So next, we're going to look at some examples for these compositions. Okay, we're going to look at some examples of these compositions. When we are handling these compositions, right? We are actually, what we are given, okay, what we are given are these two functions. And as we said earlier, this one is rarely mentioned unless otherwise specified. Okay, so that's why when in the handling of the composition of any sort. And we're really just dealing with these two functions. And these two identities, they are the shortcut. But they are just shortcuts. Okay, they are just shortcuts. So for the first one, when we need to use this property, right? It has to make sure this condition has to be satisfied. And for the other property, it can be any real number. Okay, so let's look at some examples. Okay, so the first one. Okay. The first one, I'm going to type it. I'm going to type the first example. Okay, so we have tangent. Okay, arctan of 3/2. 3/2. What would that be equal to? What would that be equal to? Think about it. Well, you probably think of the shortcut, right? Of course. And the second identity seemed to match our situation. And 3/2 is one of the real numbers. So the answer is just 3/2. 3/2. Okay, it's just 3/2. So if you know the shortcut, you know the identity, it's pretty straightforward. However, okay, I will show you another way. Okay, another way is in case that you forgot, right? So I'm not sure, or I'm just not sure, right? You could, of course, derive your own, recall the whole process, but I'm going to just show you another way anyway, because this other way sometimes is very useful, especially in the latter calculus classes. I mean, the idea of these methods, right? So hold on, I'm going to make some more space for these. So I'm going to put it over here, there, and put these two next to each other. And then I'm going to bring them down here. Okay, so it always comes with us. So let's look at the other way. Okay, how would I do it the other way? Okay, we're going to go back on the stage of trig, the 3 pillars, right? The 3 pillars. We know that, we have a y. What I'm going to do, I'm just going to get started on this rectangular system. Okay, this method actually is rather commonly used, possibly in your future calculus classes. Okay, there's not special angle. You can see it's 3/2, right? Arctangent 3/2 is not going to be a special angle, but we know that arctangent 3/2, this is the output of arctangent. So that output is going to be in the range of arctangent. Okay, that's the key. What does that mean? Okay, so let me just quickly adjust the view. And I'll show you what else can be done, right? The general method. Now, we have the standard position, of course, so we know how to measure our angles. And we know arctangent is going to be an angle. This angle is going to be in the range. So we assume that's going to be theta, right? And that theta is going to be in the range. What is the range of arctangent? The range of arctangent is from -π/2 to π/2, exclusive. Okay, you see that? It's going to be either terminate in the first quadrant or in the fourth quadrant, first or fourth, measuring from the standard position. But The other important tip is that, did I have my unit circle with me on the top? Okay, it's not on the top. Look at the unit circle. If you look at the unit circle, I'm going to find my unit circle. Okay, I need my unit circle. So I bring my unit circle with me because I'm going to show you something. Okay, so here's my unit circle. Okay, you see tangent, arctangent range is from negative pi over 2 to pi over 2. In other words, whatever you get, right? The output we're getting is going to be either measured from standard position to negative pi over 2, right? Almost touches negative pi over 2, not including negative pi over 2, or measure from standard position to positive pi over 2, just a little short of it, not including pi over 2, okay? So between negative pi over 2 to pi over 2, not including negative pi over 2 nor pi over 2. So with that said and done, right? So you can see the answer is there, but also notice, right? The arctangent ratio, they're just the blue divided by the red, all of these are going to be positive ratio. All of these are going to be positive ratio, okay? All of these terminals here will be positive ratio, and these will going to be negative ratio, right? So here our ratio is 3/2. So we can safely say the interval actually is going to be from 0 to pi over 2. Does that make sense? Even though this is not absolutely critical, but it is important to observe that. And you will see that these attention to these small details actually is very, very important. Okay, as a result, right? When we have this, we know this angle is going to be between 0 to pi, right? And we also know that tangent theta is 3/2. Right? Because that's the definition of arctangent, right? Remember we did that 2 tables, right? We did these 2 tables, right? For special angles. You tangent this, arctangent that, right? Just swap. So that's embedded in the definition. Now for this particular question, we're done, okay? And you know the angle we measured is going to be what? The angle we measured is going to be from the standard position and counterclockwise, they're going to be a theta, okay? They're going to be a theta. So this is going to be the theta. So this is a theta. There, that's a theta. And further information can be found. Okay? For example, we know the ratio is the opposite, right? By definition, is opposite over adjacent side. Then we can find sine theta, cosine theta from it. But here we don't really need it, okay? Because tangent theta by this time, right? What is tangent theta? Well, tangent of arctangent half, arctangent 3/2 is equals to tangent, and this guy is theta, right? So this piece is theta, so theta, right? And then we are told tangent theta is going to be 3/2, so we already found it. So this operation is rather straightforward. We're really just using the definition of arctangent. Okay? So that's question number 1. So either way, you're going to get the answer, which is pretty easy. You just have to recognize the composition. Okay, so let's look at the example number 2. Example number 2. Okay. And this one, we have a situation which is going to be arctan. Okay, arctan of tan of pi over 6. Pi over 6. Can we use the shortcut? Can we use the shortcut? So where the shortcut? Here's our shortcut. Right? So here our shortcut. Can we use the shortcut? Can we use one of the shortcut? Can we use the shortcut? Right? Which one matches? Well, this one doesn't, right? And this one matches, right? So we can use that shortcut. So we're gonna remove that. So we basically apply this guy, right? Apply this property. And what do we get? Does it apply? It does, right? Because arctan, tan pi over 6 is in the place of x, and pi over 6 is also in the spelled interval. Therefore, the answer to this question is just simply pi over 6. You see that? That's how we apply the rule. We apply these shortcut, right? So let's look at another one. Example number 3, right? So here we have arctan and a tan, and this time is a negative pi over 3. Okay, so let me remove that. Put it this way. Okay. Does this shortcut apply? It does, because negative pi over 3 is inside negative pi over 2 to pi over 2 inside that interval. So this answer is going to be negative pi over 3. Okay, and we are applying the same identity because the condition matches. The condition matches, right? You see, that's pretty straightforward, right? Now let's look at some other ones. Example number 4. Okay. Now, this one we have arctan of 10, 2 pi over 3. What do we get here? What do we get here? 2 pi over 3. Can we still apply the same identity? The answer is no, right? Because 2 pi over 3 is not, 2 pi over 3 is not in the spelled interval. Okay, so you don't have to say anything, but I just want to put a note here, right? This piece doesn't apply. Okay, does not apply. Okay, but you just need to know that mentally. Okay, so it doesn't apply. So what shall we do? Can we say 10 is not defined? Of course not, right? Tangent is not defined on odd number multiples of pi over 2. And we don't have an odd number pi over 2. This is 2 pi over 3, right? Therefore, we're gonna deal with this from inside out, okay? From inside out. So we're gonna deal with the first layer. Okay, the first layer. Okay, so arctan, we write down there outside, and we're gonna take care of tangent. Okay, tangent. So how do we deal with tangent 2 pi over 3? Well, the old way, right? And it's a special angle, obviously. So we are going to measure from standard position, right? Terminate at 2 pi over 3 on the unit circle, and we got a blue number, we got a red number. And so we're going to have this ratio is going to be what? What is it going to be? The blue number divided by the red number is going to be negative √3. Okay. If you need to pause and do it on the side, just in case you need that time, feel free to do that. And then arctan of negative √3. Arctan of negative √3. Remember how we handled this? When we're dealing with arctangent, right? Quadrant 2 and quadrant 3 are gone. And this is no flight zone. You cannot fly over in either way. And the output, sorry, remember, always keep in mind, okay, before you get the answer, okay, before you get the answer, okay? I know you guys probably know the answer already. Before you get the answer, whenever you see arctan or something, okay, you know the answer is going to be within that range of arctangent, which is from negative pi over 2 to pi over 2. There. Okay, before you even look for the answer. But how do you find it? How do you find that answer, right? It's just this quadrant and that quadrant, right? Your output has to be in the range of arctangent. So where do we get a negative √3? Where do we find a negative √3? Right, the blue divided by red, right? Blue divided by red. Well, this blue divided by red is going to be equals to negative √3, right? So, and how do we get to that term? How do we get that angle? That angle has to be measured from the standard position, right? Clockwise. So that's negative pi over 3. That's a negative pi over 3. Do you guys see that? Then you say, oh, could I measure this way? No, you cannot, because you'll be flying over the no flight zone, right? And can you do this way? And the answer is no, you cannot. You cannot fly over the no flight zone, period. So you just have to get there as fast as you can. So this answer, arctan of negative √3 is going to be negative pi over 3. All right. So the answer is negative pi over 3. Right. And we did those, right? Didn't we do that? We did. Arctan of negative √3 is negative pi over 3. You see, we have done it. We did it, right? Now it's just in a different, you know, as one of the steps in handling a composition question. Right? So we do it from inside out. Okay, we do it from inside out. Let's look at another one. Okay, example number 5. Okay, example number 5, we're going to see it's arctan of tan negative 7 pi over 6. Negative 7 pi over 6. Obviously, it doesn't apply. This doesn't apply, right? It's way outside. It's way outside. We cannot take any shortcut. And what do? We still do this. We still do something similar, right? We still do something similar. We do it from inside out, really, from inside out. So let's see how we do it from inside out. Right? So let me make sure I leave enough space. Right. I put both pictures here because sometimes if it's not a special angle, using this one, it could be useful, right? It's just a cleaner. It's just a cleaner. Same thing. So first we're going to deal with the inside, right? So the outside is going to set to weight there, right? So arctan. So we're waiting for an answer coming our way. And we're handling tangent -7 pi over 6. How do we handle tangent -7 pi over 6? ARD, right? ARD. So I'm going to measure from the standard position, right? -7 pi over 6. Boom. Here's the terminal. Here's the terminal, right? So this angle is -7 pi over 6. Okay. And it terminates here, and the point on the unit circle, we take the blue number, divide by the red number. The blue is positive, the red is negative. And we're already pretty familiar with that ratio. And so this piece is going to equal to -√3 over 3. Okay, so we're done. Now we know the answer, right? We also know the answer has to be where? The expected answer has to be before we get the answer. So once again, before we get the answer, we know what to expect. That's what the range tells us. Okay, range tells us before you get your answer, you already know what to expect. The scope of your answer, where would it be? Okay, so now we're going to handle arctangent of -√3 over 3. Okay, arctangent of √3 over 3. Okay, so I'm going to put that equal sign there. Okay, so I make space for it. So now we're handling arctangent. We're handling arctangent. When we are handling arctangent, quadrant 3 and quadrant 2 are out of the picture. That's no flight zone, right? So then we look for the ratio of arctangent, which is -√3 over 3. So it's in the negative ratio part. So it cannot be here. It cannot be there. So it's going to be here. So which pair of blue divided by red give us that ratio? It looks like it's going to be this pair, right? It's going to be this pair. So that's going, and how do we get there? Angle measurement. Angle measurement from standard position clockwise, because we have a negative ratio. Therefore, the angle is going to be a clockwise measurement. Okay, and that's going to be -pi over 6. That's going to be -pi over 6. I hope that makes sense to you. Okay, -pi over 6, right? And we also get the same answer. If you look what we have done before, right? I brought that table with us. Arctangent of -√3 over 3 equals to -pi over 6. That was part of the definition process. Okay, that's part of the definition for arctangent. One more example, and then let's see. Okay, this should be example number 6, isn't it? Example number 6. Yeah, example number 6. Okay, and this case, we have a arctan of tan 11 pi over 6. 11 pi over 6. So once again, this shortcut does not apply, right? Shortcut does not apply. So what do? Well, we just do it from the inside out, right? Just like as always, right? Even in the case the certain property apply, you can still do it from the inside out. Okay, you can still do it. And then you have 2 different ways of doing it. So with this expression here, right? And we got to do it from the inside out. So arctan is going to wait outside. So waiting for a number 11 pi over 6. How do we get that? So how do we handle tangent 11 pi over 6? Well, you're going to measure, right? Counterclockwise, 11 pi over 6. So this is the terminal. This is the terminal. And that ratio of blue divided by red is going to be what? What is it going to be? Is it going to be negative √3 over 3? Okay. And what's arctangent of negative √3 over 3? We just did that, right? We just did a question like that, like the other one. Well, it's going to be negative pi over 6. It's going to be negative pi over 6. Okay. I think that's all for this lesson. That's all for this lesson. And yeah, if you have any questions, please don't hesitate to reach out to me. And thank you for watching.